April 2nd, 1945, Central Germany. A small town called Bleicherode. American soldiers are moving through the rubble of a destroyed Nazi research facility. They're looking for weapons. They're looking for intelligence. They're looking for anything that might give them clues about German military capabilities. But then they find it, deep underground, built into a mountain, a massive tunnel system, and inside that tunnel system, they discover something that stops them dead in their tracks: blueprints, technical drawings, models, plans, an entire facility dedicated to building rockets. Not simple rockets, not conventional weapons, intercontinental ballistic missiles, rockets powerful enough to strike New York from Europe. Rockets so advanced that American engineers had no idea such technology even existed. One American soldier picks up a technical manual written in German. His hands are shaking, because he understands in that moment that everything has changed. The war is ending, but the future has just begun, and that future belongs to whoever controls this German rocket technology. This is the story of the V-2 rocket. This is the story of how American soldiers captured Nazi Germany's most advanced weapon. This is the story that launched the space race. This is the story that changed history. In the 1930s, as Adolf Hitler consolidated power in Germany, the Nazi regime began investing heavily in advanced military technology. The regime believed that technological superiority would compensate for Germany's numerical disadvantages against larger enemies. The regime believed that innovation could change the course of wars. One of the most visionary technologists in Nazi Germany was a man named Werner von Braun. Von Braun was a rocket scientist. He had been fascinated by rockets since childhood. He had studied engineering at German universities. He had become one of Europe's leading experts on rocket propulsion and trajectory design. In the 1930s, von Braun was working for a private German rocket society. The society was conducting experiments with rockets, but the society had limited funding. The society had limited resources. The society couldn't pursue its most ambitious projects. Then, in 1932, something changed. The German military became interested in rockets. The German military saw rockets as potential weapons. The German military wanted to develop long-range missile technology. The German military offered von Braun and other rocket scientists the opportunity to work on military rocket projects with military funding. Von Braun made a decision that would define his entire career. He decided to work for the German military. He decided to direct his brilliant mind toward developing weapons. He accepted a position in the German Army's Ordnance Department, specifically in a research facility focused on rocket development. This decision would have consequences that von Braun could not have anticipated. It would lead to the development of the V-2 rocket. It would lead to the deaths of thousands of people. It would eventually lead to von Braun becoming one of the most important figures in the American space program. But in 1932, von Braun was simply a young scientist, excited about the opportunity to pursue his passion for rockets with adequate funding and resources. The German Army's rocket research facility was located in a remote area of northern Germany called Peenemünde. The location was chosen for its isolation. The location was chosen because it was far from population centers. If rocket experiments went wrong, if rockets exploded, the damage would be limited. At Peenemünde, von Braun and his team began systematic research into rocket propulsion. They designed rockets, they tested them, they analyzed the results, they made improvements, they designed better rockets, they tested them again. The early rockets were small, they were crude. They could barely reach altitudes of a few hundred meters. But von Braun and his team persisted. They understood the principles of rocket flight. They understood trajectory mechanics. They understood the mathematics of ballistic motion. Year by year, the rockets became larger. The rockets became more sophisticated. The rockets could fly higher. The rockets could travel farther. By the late 1930s, German rockets were achieving altitudes of several kilometers and ranges of dozens of kilometers. But von Braun and his superiors understood that these experimental rockets were just the beginning. They had a much more ambitious goal: to develop a rocket that could travel hundreds of kilometers. A rocket that could carry a heavy warhead. A rocket that could strike targets across Europe. This rocket became known as the V-2. The V stood for Vergeltungswaffe, which means vengeance weapon in German. The Nazi regime believed that the V-2 would be an instrument of vengeance against their enemies. The Nazi regime believed that the V-2 would change the course of the war. The V-2 was an engineering marvel. It was 56 feet tall. It weighed 28 tons at launch. It was powered by a liquid rocket engine that burned alcohol and liquid oxygen. The engine produced tremendous thrust. The engine could accelerate the rocket to supersonic speeds. The rocket was guided by sophisticated control systems. Gyroscopes provided stability. Accelerometers measured acceleration. Radio commands from the ground could adjust the rocket's trajectory. The rocket could hit targets hundreds of kilometers away with reasonable accuracy for a weapon of that era. The V-2 represented a revolutionary leap in military technology. Nothing like it had ever been built before. No other nation possessed anything remotely similar. The V-2 was a weapon that existed in the future. It was technology that should not have existed in 1945. Peenemünde was unlike any military facility that American or British planners had ever encountered. It was a sprawling complex devoted entirely to rocket research and development. It had laboratories where scientists conducted theoretical research. It had engineering shops where technicians built rocket components. It had testing facilities where rockets were assembled and tested. It had enormous gantries where rockets were mounted for launch. It had bunkers and shelters to protect personnel and equipment from air attack. The facility employed thousands of people. There were scientists and engineers. There were skilled technicians. There were laborers. There were security personnel. The facility was one of the most secret installations in Nazi Germany. Few people outside the military hierarchy knew that Peenemünde existed. The British and American military intelligence services eventually learned about Peenemünde. They learned that the Germans were developing some kind of advanced weapon. They didn't know exactly what, but they knew it was important. They knew it was secret. They knew it must be destroyed. In August 1943, the Royal Air Force and the United States Army Air Forces launched a massive bombing campaign against Peenemünde. Hundreds of bombers attacked the facility. Many bombs hit their targets. Many buildings were destroyed. Many people were killed. The bombing campaign caused significant damage to the facility. But the damage was not as devastating as the Allies hoped. The Germans had anticipated bombing attacks. The Germans had built underground facilities that could withstand bomb blasts. The Germans had dispersed important equipment. Some of the most critical rocket development work continued even after the bombing. Moreover, the bombing had an unexpected effect. It convinced Hitler that the V-2 rocket was worth any cost. He increased funding for the program. He ordered that the program be accelerated. He believed that the V-2 would be a decisive weapon that could turn the tide of the war. Under this increased pressure, von Braun and his team worked frantically to complete the V-2. They refined the design. They solved technical problems. They conducted extensive testing. By 1944, the V-2 was ready for production and deployment. The Germans began launching V-2 attacks against targets in Europe. The V-2s struck London. They struck Antwerp. They struck other cities. Each V-2 that successfully reached its target demonstrated that German rocket technology was superior to anything the Allies possessed. The V-2 attacks alarmed Allied military planners. They realized that the Germans had developed a weapon that the Allies had no effective defense against. The V-2 was too fast to intercept. The V-2 was too high to reach with anti-aircraft fire. The V-2 was fundamentally a new type of weapon that required new defensive strategies. But by 1945, the German military situation was becoming desperate. Germany was losing the war on all fronts. The Soviet army was advancing from the east. The American and British armies were advancing from the west. Germany's defeat was inevitable. As Germany's military situation deteriorated, military planners in America and the Soviet Union began thinking about what would happen after the war. They began thinking about German military technology. They began thinking about German scientists and engineers. The Germans had developed remarkable weapons. The Germans had developed advanced aircraft. The Germans had developed sophisticated radar systems. The Germans had developed the V-2 rocket. After the war, whoever possessed these technologies would have significant military advantages. American military leadership understood this. They understood that capturing German scientists and German technology should be a priority as the war came to an end. They understood that they were in a race with the Soviet Union. The Soviet Union would also be trying to capture German scientists and German technology. The Soviet Union would also understand the value of German rocket technology. American military planners developed a secret program called Operation Paperclip. The goal of Operation Paperclip was to identify and capture German scientists. The goal was to bring them to America. The goal was to have them continue their research work for the American military. The goal was to ensure that American military technology remained superior to Soviet military technology after the war. Special teams were organized. These teams were given orders to move ahead of regular military forces. Their mission was to reach German research facilities before Soviet forces could reach them. Their mission was to secure German scientists. Their mission was to prevent German technology from falling into Soviet hands. The search for the V-2 rocket facility became one of the highest priorities. American military planners knew that the V-2 represented revolutionary technology. They knew that Soviet scientists would be equally interested in this technology. They knew that the race to capture the V-2 facility and its scientists would determine who would lead the world in rocket technology after the war. As the war in Europe came to an end, American forces advanced rapidly through German territory. Soldiers moved from town to town. They encountered German resistance. They captured German prisoners. They gathered intelligence about German military facilities. Among the intelligence that American soldiers gathered was information about a secret rocket facility hidden in an underground fortress near the town of Bleicherode in central Germany. The intelligence indicated that the facility contained V-2 rockets and V-2 technology. The intelligence indicated that German scientists were working at the facility. American military commanders understood the importance of this facility. They understood that this facility might contain the most advanced German rocket technology. They understood that this facility might contain Werner von Braun and other key German rocket scientists. American military planners made the capture of this facility a priority. They ordered American forces advancing through that region to locate the facility and capture it intact. They ordered that German scientists at the facility should be captured and protected. They ordered that all technical documents, blueprints, and equipment at the facility should be preserved. When American soldiers finally reached the underground fortress near Bleicherode, they discovered that many of the German scientists and technicians had already fled. Some had gone south, following retreating German military units. Some had hidden in the surrounding countryside. Some had tried to escape to Switzerland or other neutral countries. But the facility itself remained largely intact. The underground tunnels were intact. The technical documents were there. The equipment was there. The blueprints were there. The models of rockets were there. American soldiers had captured an enormous treasure trove of German rocket technology. The soldiers were astonished by what they found. The complexity of the facility was beyond anything they had expected. The sophistication of the equipment was beyond anything they had imagined. The technical documentation was extensive and detailed. The Germans had developed rocket technology that was years ahead of anything the Americans or the British possessed. American military officers at the scene immediately recognized the importance of what they had found. They ordered that the facility be secured. They ordered that all technical documents be carefully collected and preserved. They ordered that they begin searching for German rocket scientists who could explain how the technology worked. One of the most important objectives for American military planners was to locate Werner von Braun. Von Braun was the leading German rocket scientist. Von Braun understood the V-2 rocket better than anyone. Von Braun could explain how the technology worked. Von Braun could explain how to build V-2 rockets. But where was von Braun? When American forces reached the V-2 facility at Bleicherode, von Braun was not there. He had fled as German military forces retreated. American commanders issued orders: find Werner von Braun, bring him to American military custody. Military intelligence officers began investigating. They interviewed German prisoners. They examined records. They gathered information about von Braun's location. The investigation gradually revealed that von Braun had fled south, toward the Alps. He was attempting to reach Switzerland or Austria, perhaps hoping to hide or to negotiate with Swiss authorities. American military units accelerated their advance into southern Germany. They were racing against Soviet forces that were also advancing rapidly through German territory. They were racing to reach German rocket scientists before Soviet forces could capture them. The race intensified when intelligence indicated that von Braun and other German rocket scientists were hiding in a small village in the Bavarian Alps. American forces rushed to the location. When they arrived, they found von Braun and about 150 other German rocket scientists and engineers who had gathered together, hoping to surrender to the Americans rather than to the Soviets. Von Braun was brought into American military custody. He was interrogated. He was asked detailed questions about his work. He was asked about the V-2 rocket. He was asked about the technical capabilities of the rocket. He was asked about German plans for advanced rocket development. Von Braun cooperated fully with American interrogators. He understood that his fate depended on convincing the Americans that he was valuable. He understood that if he was handed over to the Soviets, his fate would be uncertain. So von Braun told American interrogators everything they wanted to know about German rocket technology. American military planners quickly realized that von Braun and the other German rocket scientists were extraordinarily valuable. These were the men who had developed the V-2 rocket. These were the men who understood advanced rocket propulsion. These were the men who could accelerate American rocket development by years. The decision was made. Von Braun and the other German rocket scientists would be brought to America. They would be given the opportunity to continue their rocket research work for the American military. They would help America develop military rockets and eventually space launch vehicles. This decision was controversial. Many Americans believed that German scientists who had worked for Nazi Germany should be prosecuted as war criminals. Many Americans believed that German scientists should not be trusted. But military planners believed that the technological advantages that German rocket scientists could provide outweighed the political and ethical objections. As American engineers and scientists examined the V-2 facility at Bleicherode, they became increasingly astonished by the sophistication of German rocket technology. The V-2 rocket itself was a marvel of engineering. The rocket was 56 feet tall. The rocket was made of aluminum alloy. The rocket had a streamlined shape designed to minimize air resistance at high speeds. The rocket could reach altitudes of 50 miles and strike targets at ranges of over 200 miles. The rocket engine was particularly impressive. The engine was a liquid rocket engine that burned alcohol and liquid oxygen. The engine produced tremendous thrust. The engine had to be precisely engineered to function properly. The combustion chamber had to withstand extreme temperatures and pressures. The fuel injectors had to atomize fuel and oxidizer perfectly. The cooling system had to prevent the engine from melting during operation. American engineers examined the engine specifications. They analyzed the design. They were shocked at how sophisticated the design was. American rocket engineers at that time had no experience building liquid rocket engines at this scale. American rocket engineers had never built anything like the V-2 engine. The guidance and control systems of the V-2 were equally impressive. The rocket had gyroscopes for stability. The rocket had accelerometers to measure acceleration. The rocket had radio receivers to receive guidance commands from the ground. The rocket had mechanical and electronic systems that could adjust the rocket's trajectory during flight. American engineers had never seen electronic systems this sophisticated in a military weapon. The Germans had miniaturized electronic components. The Germans had developed automated control systems. The Germans had built systems that could function reliably under extreme conditions. The technical documentation that American engineers found at Bleicherode was extensive. There were blueprints. There were design specifications. There were test data. There were manufacturing procedures. The Germans had documented their work in meticulous detail. American engineers could study the documentation and understand exactly how the V-2 was designed and built. American military planners realized the implications immediately. This was technology from the future. This was technology that was years ahead of anything America possessed. This was technology that could fundamentally change military strategy. This was technology that could eventually lead to spaceflight. When von Braun and the other German rocket scientists arrived in America, they were placed in facilities where they could work under military supervision. The American military wanted to understand every detail of V-2 rocket technology. The American military wanted to know how to build V-2 rockets. The American military wanted to know how to improve upon V-2 rocket design. Von Braun became the chief technical advisor on the American V-2 rocket program. He provided detailed explanations of how every component of the V-2 worked. He explained the design philosophy behind the rocket. He explained the engineering challenges that the Germans had overcome. He explained the compromises that the German design made between performance, reliability, weight, and manufacturability. American engineers listened intently. American engineers took notes. American engineers began learning from the German experts. One of the most important things that von Braun taught American engineers was how to think about rocket design. The Germans had approached rocket design with a systems perspective. Every component of the rocket had to work together. Every component had to be optimized. The entire rocket had to be engineered as an integrated system. Von Braun taught American engineers about combustion chamber design. He taught them about fuel injection. He taught them about cooling systems. He taught them about materials that could withstand extreme temperatures and pressures. Von Braun taught American engineers about guidance and control systems. He taught them about gyroscopes. He taught them about accelerometers. He taught them about electronic systems for rocket guidance. Von Braun taught American engineers about launch procedures. He taught them about fueling procedures. He taught them about countdown procedures. He taught them about safety procedures. American engineers were absorbing knowledge that the Germans had accumulated through years of research and development. Knowledge that had been expensive to acquire. Knowledge that had been purchased with German blood and treasure. Knowledge that was now being transferred to America. As American engineers studied the V-2 rocket in detail, they began to understand what made it so advanced. The first advantage was scale. The V-2 was enormous compared to anything America had built. American rockets of that era were much smaller. American rockets could reach altitudes of a few hundred feet. The V-2 could reach altitudes of 50 miles. The difference in scale required completely different approaches to engineering. The second advantage was the liquid rocket engine. American rocket engineers had limited experience with liquid engines. They had built small liquid engines for experimental purposes, but they had never built a large liquid engine like the V-2 engine. The V-2 engine produced over 50,000 pounds of thrust. This was power on a scale that American engineers had never attempted. The third advantage was integration. The V-2 was not just a rocket engine attached to a fuel tank. The V-2 was an integrated system where every component was optimized to work together. The structure of the rocket was designed to be as light as possible, while still being strong enough to withstand launch stresses. The fuel system was designed for efficiency. The guidance system was designed to work with the rocket's aerodynamics. Every component was optimized for the entire system. The fourth advantage was the guidance and control systems. The V-2 had electronic systems that could adjust the rocket's trajectory during flight. The V-2 had radio receivers that could receive guidance commands. The V-2 had accelerometers and gyroscopes that provided feedback to the control systems. This level of sophistication in guidance and control was far beyond what American engineers had attempted. The fifth advantage was manufacturability. The Germans had figured out how to manufacture the V-2 in quantity. The Germans had designed the rocket in a way that could be built by workers of varying skill levels. The Germans had developed manufacturing procedures that ensured quality and consistency. The Germans had built a production system that could produce hundreds of V-2 rockets. As American engineers studied all these advantages, they began to understand the scope of the task ahead. America was going to have to completely revise its approach to rocket development. America was going to have to learn from the Germans. America was going to have to catch up to German rocket technology. The capture of German V-2 rocket technology marked a turning point in human history. It marked the beginning of the space age. It marked the beginning of the American space program. It marked the end of an era when rockets were simply military weapons and the beginning of an era when rockets could become vehicles for space exploration. In the years immediately after World War II, American rocket engineers worked intensively to understand and reproduce V-2 rocket technology. They analyzed the technical documentation. They studied captured V-2 rockets. They worked with German rocket scientists. They conducted tests. They refined designs. American companies like North American Aviation, Rocketdyne, and others began building rocket engines based on the principles that the Germans had developed. American missile programs began developing intercontinental ballistic missiles based on V-2 design principles. American space programs began developing rockets for space exploration. The influence of German rocket technology on American rocket development cannot be overstated. The Redstone missile that carried the first American astronauts was directly descended from V-2 technology. The Saturn V rocket that carried Americans to the moon was built by the same organization that von Braun founded after arriving in America. The space shuttle used rocket engines based on principles that the Germans had developed. Without the capture of German rocket technology at the end of World War II, American rocket development would have taken a different path. America might have developed rockets more slowly. America might never have achieved the level of rocket technology that eventually allowed Americans to reach the moon. The Soviet Union also captured German rocket technology and German rocket scientists. Soviet rocket engineers learned from German V-2 technology just as American engineers did. The Soviet Union developed the R-7 intercontinental ballistic missile, which was directly based on V-2 design principles. The Soviet Union used the R-7 to launch Sputnik, the first artificial satellite. The competition between America and the Soviet Union to develop superior rocket technology drove the space race of the 1960s. The space race drove innovation. The space race led to the Apollo program. The space race led to humans walking on the moon. None of this would have happened without the capture of German rocket technology. None of this would have happened without Werner von Braun and the other German rocket scientists. None of this would have happened without American soldiers discovering the V-2 facility at Bleicherode and American military leadership deciding that German rocket scientists were valuable assets rather than enemies to be punished. Werner von Braun spent the rest of his life working on American rocket programs. Von Braun became a United States citizen. Von Braun became the chief rocket scientist for the American military. Von Braun became the director of NASA's Marshall Space Flight Center. Von Braun worked on the Redstone missile program. Von Braun worked on the Jupiter missile program. Von Braun worked on the Saturn V rocket program. Von Braun was directly involved in the development of the rockets that carried Americans to the moon. Von Braun became one of the most important figures in the history of space exploration. Von Braun was also one of the most controversial figures because of his work for Nazi Germany. Some people believed that von Braun should have been prosecuted as a war criminal. Some people believed that the V-2 rockets that von Braun designed killed thousands of civilians when they struck London and other cities. Von Braun himself acknowledged this controversy. In later life, von Braun said that he had concentrated on the technical aspects of rocket development and had tried not to think about the military applications of his work. Whether this explanation is satisfactory is a matter of debate. What is certain is that von Braun's decision to work for the American military after World War II had profound consequences. It accelerated American rocket development. It contributed to American military superiority during the Cold War. It enabled the Apollo program. It enabled humans to walk on the moon. One of the most striking things about the V-2 rocket was how advanced it was for 1945. In many respects, the V-2 was more advanced than American rockets being built in the 1950s, 10 years later. The V-2 used a double-base propellant mixture of alcohol and liquid oxygen. This propellant combination had been chosen by the Germans because it provided good specific impulse, good density, and good combustion characteristics. American rocket engineers initially considered using different propellant combinations, but they eventually came to understand the wisdom of the German choice. Alcohol and liquid oxygen became the standard propellant combination for many American rockets. The V-2 engine had a regenerative cooling system. The fuel passed through cooling jackets that surrounded the combustion chamber before being injected into the engine. This cooling approach prevented the combustion chamber from melting during the extreme temperatures of combustion. American rocket engineers had not previously considered regenerative cooling. This concept was revolutionary to American engineers. Regenerative cooling became the standard approach for American rocket engines. The V-2 guidance system used mechanical and electronic systems to adjust the rocket's trajectory. The rocket had accelerometers that measured the rocket's acceleration. The rocket had gyroscopes that measured the rocket's orientation. The rocket's guidance computer processed this information and commanded corrections to the rocket's flight path. This level of automated control was extraordinary for 1945. American engineers had not built anything like it. American rocket engineers studied every detail of V-2 technology and incorporated what they learned into American rocket designs. American rockets became more efficient. American rockets became more reliable. American rockets became more powerful. The transfer of German rocket technology to America accelerated American technological progress by years. The capture of German rocket scientists brought German expertise directly to American rocket programs. The combination of German technology and American industrial capability created a powerful force for rocket development. While American rocket engineers were learning from German V-2 technology, Soviet rocket engineers were doing the same thing. The Soviet Union had also captured V-2 rockets and V-2 technology. The Soviet Union had also captured German rocket scientists. Soviet engineers under the direction of Sergei Korolev studied V-2 technology and incorporated what they learned into Soviet rocket designs. Soviet rocket engineers developed the R-1 rocket, which was essentially a copy of the V-2. Soviet rocket engineers then developed the R-2 and R-5 rockets, which were improvements on V-2 design. The competition between America and the Soviet Union to develop superior rocket technology became the driving force behind the space race. Each side tried to develop rockets that were more powerful, more reliable, and more capable than the other side's rockets. The Soviet Union developed the R-7 intercontinental ballistic missile, which was descended from V-2 technology but was more advanced. The R-7 could carry a nuclear warhead to American territory. The R-7 was a source of great concern to American military planners. But the R-7 also had another use. The R-7 could launch a satellite into orbit. In 1957, the Soviet Union used an R-7 rocket to launch Sputnik, the first artificial satellite. Sputnik shocked the American public. Sputnik demonstrated that the Soviet Union had advanced rocket technology. Sputnik started the space race. American military planners and American political leaders were alarmed by Sputnik. They believed that Soviet rocket technology was superior to American rocket technology. They demanded that America develop rockets and space vehicles that could match or exceed Soviet capabilities. This demand led to the creation of NASA in 1958. This demand led to the American space program. This demand led to the decision to put Americans on the moon. This demand drove the Apollo program. Von Braun became the leading advocate for the American space program. Von Braun argued that America could reach the moon if given adequate funding and support. Von Braun led the development of the Saturn V rocket. Von Braun's Saturn V rocket became the most powerful rocket in the world. The Saturn V rocket launched Americans to the moon. The transition from the V-2 as a weapon to rockets as vehicles for space exploration was not instantaneous. In the 1950s, rockets were still primarily military weapons. The primary purpose of rocket development was to develop intercontinental ballistic missiles that could carry nuclear warheads. But as American engineers became more familiar with rocket technology, they began to understand the potential for space exploration. They understood that rockets could potentially carry payloads to the moon. They understood that rockets could potentially carry humans into space. They understood that rockets could potentially create vehicles for space travel. Von Braun became one of the leading advocates for space exploration. Von Braun wrote articles about the possibility of space stations. Von Braun wrote articles about the possibility of journeys to the moon. Von Braun wrote articles about the possibility of journeys to Mars. Von Braun promoted the idea that space exploration was not just technically possible, but was something that humanity should pursue. In the late 1950s and early 1960s, American political and military leadership came to accept that space exploration was a worthy goal. American leadership came to accept that space exploration was important for national prestige. American leadership came to accept that space exploration was important for military strategy, because whoever controlled space might have military advantages in future conflicts. This acceptance led to the decision to put Americans on the moon. President John F. Kennedy committed America to landing on the moon before the end of the 1960s. This commitment drove the Apollo program. This commitment led to the development of the Saturn V rocket. This commitment led to humans walking on the moon. None of this would have happened without the capture of German V-2 rocket technology at the end of World War II. The trajectory of human history was changed by American soldiers discovering the V-2 facility at Bleicherode. The story of German rocket technology and German rocket scientists raises profound ethical questions. Werner von Braun worked for Nazi Germany. Von Braun designed rockets that killed civilians. Von Braun had connections to the Nazi regime, although the degree of his commitment to Nazi ideology is debated by historians. After the war, von Braun was brought to America. Von Braun was given the opportunity to continue his rocket work. Von Braun became a respected figure in American society. Von Braun became a hero of the space age. Some people believe that von Braun should have been prosecuted as a war criminal. Some people believe that the rockets he designed while working for Nazi Germany resulted in sufficient loss of life that he should have faced justice. Some people believe that von Braun's later contributions to space exploration do not erase his past. Other people believe that von Braun was a genius who was exploited by the Nazi regime. They believe that von Braun concentrated on the technical aspects of rocket design and tried to avoid thinking about the military applications. They believe that after the war, von Braun made positive contributions to human progress through his work on the American space program. The truth is probably more nuanced than either extreme position. Von Braun was a brilliant engineer who made extraordinary contributions to rocket technology. But von Braun was also a person who designed weapons for Nazi Germany. Von Braun was a person who benefited from the Nazi regime's resources and support. Von Braun was a person who knew that his rockets were being used to kill people. The decision by American military and political leadership to bring von Braun to America and give him the opportunity to continue his work was pragmatic from a Cold War perspective. But the decision also raises moral questions about justice and accountability. The decision prioritized military and technological advantage over justice. Similar questions apply to other German scientists who were brought to America after the war. American leadership decided that technological advantage was more important than prosecuting people for their roles in the Nazi regime. American leadership decided that German scientists could contribute more to American security and progress than they could contribute to justice. These were not easy decisions. These were decisions made in the context of the emerging Cold War. These were decisions made by people who believed that the Soviet Union posed an existential threat to America. These were decisions made by people who believed that American security depended on superior military and technological capabilities. Whether these decisions were right or wrong is a matter of perspective. What is certain is that the decisions had profound consequences for human history. The decisions shaped the course of the space age. The decisions shaped the course of the Cold War. The decisions shaped the future that humanity would experience. The capture of V-2 rocket technology was just one example of how American military planners sought to capture German military technology at the end of World War II. American military planners also sought to capture German jet engine technology. American military planners found German jet engines and German jet engine designers. American jet engine manufacturers began building jet engines based on German designs. American military planners also sought to capture German radar technology. American military planners found German radar systems and German radar engineers. American radar manufacturers began building radar systems based on German designs. American military planners also sought to capture German aircraft designs. American military planners found German aircraft manufacturing facilities. American aircraft manufacturers began building aircraft based on German designs, or incorporating German design principles into American aircraft. The broader pattern was clear. American military planners believed that German technology was advanced. American military planners believed that American military and technological advantage depended on capturing German technology and German scientists. American military planners were willing to bypass normal legal and ethical procedures to accomplish these objectives. This pattern of capturing German technology and German scientists was followed by military planners in the Soviet Union as well. Soviet military planners also captured V-2 rockets and V-2 technology. Soviet military planners also captured German rocket scientists. Soviet military planners also captured German jet engines, radar technology, and other military technology. The competition between America and the Soviet Union to capture German technology drove technological development in both countries after the war. Both countries benefited from German technological advances. Both countries incorporated German technology into their own military and civilian applications. The capture of German technology and German scientists had profound consequences for Germany itself. Germany lost access to its most advanced military technology. Germany lost access to its most talented scientists and engineers. Many of Germany's best scientists emigrated to America, the Soviet Union, or other countries. Germany's scientific and technological community was decimated. Germany's capacity for technological innovation was severely damaged. In the years after the war, Germany had to rebuild its scientific and technological base from scratch. Germany had to develop new scientific institutions. Germany had to train new scientists and engineers. Germany had to rebuild its technological capabilities. Over the following decades, Germany rebuilt itself as a modern technological powerhouse. Germany developed advanced industries. Germany developed world-class scientific institutions. Germany became a leader in automotive technology, chemical technology, and other fields. But in the immediate post-war period, Germany was stripped of much of its technological leadership. The brain drain of German scientists and engineers to America and the Soviet Union damaged Germany's capacity for technological innovation. The loss of access to advanced German military technology meant that Germany could not develop military weapons on its own. Germany became militarily dependent on the United States and NATO for its security. Operation Paperclip, the American program to capture German scientists and bring them to America, became one of the most significant scientific and technological programs of the post-war era. Through Operation Paperclip, America obtained not just Werner von Braun, but hundreds of other German scientists and engineers. These scientists and engineers brought with them knowledge and expertise that had been accumulated through years of research and development. They brought with them technical documents and technical knowledge. They brought with them a different approach to engineering and scientific research. American military and technological institutions benefited enormously from the influx of German scientists and engineers. American rocket programs benefited from German rocket scientists. American jet engine programs benefited from German jet engine designers. American radar programs benefited from German radar engineers. American aircraft design programs benefited from German aircraft designers. The influx of German scientists contributed to American technological dominance in the post-war era. The influx of German scientists contributed to American military superiority during the Cold War. The influx of German scientists contributed to American space achievements. Operation Paperclip remains controversial. Critics argue that Operation Paperclip allowed people who had worked for Nazi Germany to escape prosecution. Critics argue that Operation Paperclip prioritized military and technological advantage over justice and accountability. Critics argue that Operation Paperclip set a dangerous precedent for the use of captured enemy scientists in post-war programs. Supporters of Operation Paperclip argue that the program was pragmatic and necessary. Supporters argue that American security during the Cold War depended on technological superiority. Supporters argue that American technological achievements, including space exploration, depended on the knowledge and expertise that German scientists brought to America. The capture of German V-2 rocket technology enabled technological futures that would not have been possible otherwise. American rocket technology developed directly from German V-2 technology. American rockets of the 1950s were recognizably descended from V-2 design. American rockets of the 1960s incorporated more advanced design concepts, but those concepts were built on the foundation of V-2 technology that German scientists had developed. The Saturn V rocket that took Americans to the moon was built by the same organization that Werner von Braun founded. The Saturn V rocket used rocket engines that were descended from V-2 technology. The Saturn V rocket used guidance and control systems that incorporated principles that German scientists had developed. Without German V-2 rocket technology, America might have developed rockets more slowly. America might have followed a different technological path. America might never have developed the rockets necessary to reach the moon. The Soviet Union's space achievements also depended on German V-2 technology. The Soviet R-7 rocket that launched Sputnik was based on V-2 design principles. Soviet achievements in space exploration depended on German rocket technology. The space age itself was enabled by German rocket technology. The satellites that orbit Earth, the space stations that humans live in, the interplanetary probes that have explored the solar system, the moon landing. All of these achievements ultimately depended on rocket technology that was descended from the V-2 rocket that German scientists developed during World War II. The story of German V-2 rocket technology and how America captured it and how it enabled space exploration teaches several important lessons. The first lesson is that technological advantage can be more important than military victory in determining the outcome of geopolitical competition. America defeated Germany in World War II, but American military planners recognized that capturing German technology would provide advantages in the emerging Cold War with the Soviet Union. American military planners prioritized technological advantage over other considerations. The second lesson is that human beings are repositories of knowledge and expertise that can be transferred across national boundaries. Werner von Braun and the other German scientists brought with them decades of accumulated knowledge. They brought with them a different approach to engineering and scientific research. They brought with them the ability to accelerate American technological development by years. The third lesson is that technological development is not inevitable or predetermined. Human history could have followed a different path if American military planners had made different decisions. If American military planners had decided to prosecute German scientists as war criminals, if American military planners had decided not to prioritize the capture of German technology, if American military planners had made different choices, the trajectory of human technological development would have been different. The fourth lesson is that the ethical dimensions of technological development cannot be ignored. German rocket scientists designed weapons that killed civilians. Those scientists were later brought to America and given prominent positions. The ethical costs of this decision cannot be completely erased by the later technological achievements of these scientists. The fifth lesson is that wars have consequences that extend far beyond the military conflict itself. The consequences of World War II shaped the space age. The consequences of World War II shaped the Cold War. The consequences of World War II shaped the future that humanity would experience.